Hi everyone, my name is Catherine Marriott. I am a master's candidate at Brooklyn College in the City University of New York. Today I'll be discussing extrapolating ammonite hemisuture analysis from partial or lateral suture components. Ammonite sutures are measured fractally. A fractal is a mathematical phenomenon of self-repeating subdivisions such as the Koch snowflake seen on the right. The step method is used to generalize a fractal dimension expressed as df, and the df of true fractals is between 1 and 2. The step method, when used on ammonite sutures, generally measures a full hemisuture or half suture going between the external lobe E and the furthest away umbilical lobe U1. We then generalize the shape of the hemisuture based on step lengths, which are usually chosen as either a fraction of the hemisuture length, which is what I've done here, or as a finite millimeter count. So as I mentioned, these are fractions. The green line represents 1/5 the hemisuture length, the magenta represents 1/10 the hemisuture length, and the blue represents 1/15 of the hemisuture length. So to calculate my fractal dimension using the blue lines, we would say the fractal dimension equals the log of the number of steps, which is 90, over the log of the number of units in the step, which is 15. And this answer would come out to 1.662 rounded to 3 decimal places. However, it's not always possible to have a full hemisuture available, and so our method deals with what you would do in the case that you only have part of a suture. So instead of taking the full hemisuture length, we're measuring from the base of the lateral lobe to the base of its adjacent saddle. We're again using the same colors, green for 1/5, magenta for 1/10, and blue for 1/15. In our method, we do converted fractal, or CF, equals the log of the number of steps divided by a conversion value, which I'll get into in just a minute, all divided by the same number of divisions or units. So to show you how I found the conversion value for this ammonite and the ones related to it, this is Eogadrius numidum, which is lithoscertid. And so just taking the 1/5 measurements as an example, you'll see that we have twice as many steps in our method as in theirs. We have nearly twice as many steps for 1/10. It's not perfect, but it's very close. And for 1/15, we have twice as many steps in our method as the hemisuture method. So if we calculate the df for 1/5, we would do the log of the number of steps divided by the log of the number of units, which is 5. And this equals 1.683. If we're doing the same thing for our CF, it equals the log of the number of units, which is 30, divided by our conversion value, all over the log of the number of units. And this equals 1.683. So as I mentioned, it's not perfect, but it's very close. Our correlation coefficient is close to 94%. And I have some different genera listed here. I've calculated the fractal step to the conversion value, for some of the most common genera that you're likely to encounter, based on 60 or more measurements for each genus. So the significance of this method primarily is that it works when you're working from photographs, and it allows you to use ammonites that you wouldn't be able to come in contact with due to geography or a pandemic. The method also allows you an ontogenetic focus, which previous methods did not, because as you can see, once new shell growth covers the older part of the shell, you're no longer able to get the full hemisuture without destroying your shell. And this allows you a certain ontogenetic focus, whether you're just comparing the ontogeny of one ammonite or many ammonites. And that's all I have for you guys. Thank you very much for listening.